get started. Assignments? Oh, man. Any questions about the announcements? In this course, you sure don't want to let that project, you know, need to get that project in, okay? So, very good. The other thing is, we're still going to put together a review video, and I gave you one of the review sheets. Here's a review sheet for you. And you can go ahead and get credit for it from home, but you'll need to, this is my first time doing this, I was thinking about this, I will embed two codes and code words in there. So it'll say, I think I'll probably even write it on the sheet, you know, code word block. Okay. And
Oh, you're saying it would be like obvious and what it
yes,
is? Okay.
yes. And if you just get one, don't get two, let me know. But this is an experiment.
Okay.
So that's what you'll need to do to get credit. All right. So air masses. Good stuff. So when I think about, I'm going to grab a globe. You know, we talked a lot about reasons why a location would be warm near the equator and cold near the poles, blah, blah, blah. Okay, but the thing is a lot of times we'll be right here and we'll have temperature swings that, you know, like it's supposed to be like 10 degrees warmer in 2 days, right? So you're like, what's up with that? And a lot of times it's this idea of an air mass. Basically a chunk of air that started up here, sat for about 2 weeks. I think it takes 2 weeks. It picked up characteristics of being cold, and then it moved down. Or it sat down here for 2 weeks, picked up characteristics of being warm, and then it moved up. Okay? So we're going to talk about air masses. Air masses come in temperatures, like warm or cold. They also come in moisture content. So there are 5 types of air masses, and here are 2 of the 5 types. The clouds kind of give it away. You can't tell that it's warm. But this one right here is something called a Maritime, little m, capital T, Tropical. So we're going to use 2 letters to designate these 5 different air masses. So this is Maritime Tropical. Maritime meaning moist, tropical meaning hot. This kind of looks cold, right? And so we use the word, the polar for something that's cold, a capital P, and this is continental. So we'll put a little c, continental polar. So it's dry. So we use the word continental, cold polar. So that's chunks of air that has sat and picked up those characteristics to become an air mass. So an air mass is a large chunk of air. It's like, I don't know, a third the size of North America sort of thing. Okay, it's an air mass. And actually this is on your review sheet. So I recently made up the test. What an air mass, what all the cute little gas particles or within that air mass have in common is they have uniform temperature and moisture. I guess the particles don't have moisture, but that chunk of air generally has the same temperature and moisture at kind of horizontal layers. Chapter 9, we're going to get to tonight too, and we're going to talk about basically a weather front, and that's where 2 air masses meet. Okay, so that zone is like a front between armies. Okay, so that's the chapter 9. So if you think about trying to let a chunk of air set for 2 weeks and then it's going to be on the move, you're like, what would make a good location for that? Well, it needs to be big, and it needs to be flat because that thing's going to move afterwards, and it needs to have uniform temperature and moisture. Those are the 2 things we're going to try to condition our air mass for. Okay, so those are things that make a good source region. Okay, so source region by definition is that place it's going to sit for a couple of weeks and hang out. So notice that these the Ferrel cell, which is kind of the middle cell, because you got Hadley and Polar and Ferrel's in the middle. The Ferrel cell doesn't make a good place for source regions. The high latitudes, the polar cell, or the lower latitudes, the Hadley cell, make a lot better. All right. So, like I said, air masses are going to be characterized by how warm they are. You know, tropical is going to be warm, polar is going to be cold, or how much moisture they have. So, we'll talk just a little bit about stability or instability. And while I'm thinking about it, next to this word unstable, if the air mass has a degree of moisture, we're going to call that maritime. Remember, well, it's not going to be on a slide, but M stands for maritime, not moist, but it works just the same. Then it will be unstable, and if it's warm, okay, it'll also be unstable. All right. So it kind of reminds me of the clouds. You know how we kind of mixed and matched the flat and the fluffy clouds and the middle clouds and the high clouds and the low clouds. So we kind of mixed elevation with whether they were flat or fluffy. And we also threw in kind of a prefix for clouds, the nimbo, if they were precipitating. So we kind of do the same thing with these five air mass types, starting with their temperature. And these are in caps. So T is very hot, P is cold, and well, I guess T doesn't have to be very hot, but T is warm, P is cold, and A is very cold. So we kind of mix and match it, and with that, like you saw these two air masses that we started out with, we say something not only about temperature, but we say something about the moisture content. So, but we refer to the moisture content back to its source region. So something that had a continental source region is going to be dry. You know, it's over land, continental's land. Something that had a maritime source region, you're thinking oceans, it's going to be moist, okay? So we kind of put these little letters for dry and moist, continental and maritime, respectively, with the temperatures. So 5 air mass types coming up. So continental tropical. Continental meaning dry, tropical meaning warm. Continental polar, continental meaning dry, polar meaning cold. Maritime tropical, maritime meaning moist, tropical meaning warm. So you just kind of break it down that way. Maritime polar, maritime meaning moist, polar meaning cold. And then we have the very cold, continental Arctic. So continental meaning dry, Arctic meaning very cold. So notice what's not here. Sometimes your textbook might have a question, I'm not sure. The 6th one should be very cold, so it's Arctic, but moist. Maritime Arctic. Like, where is that? Well, the old adage and the thing that we talked about, that cold air, bitterly cold air, holds very little moisture. That's kind of where we're coming with that. So Arctic air, you're not going to get moist. So there is no maritime Arctic air mass. So in the next chapter, like I said, you know, when these air masses meet, that's where life gets really interesting, right? The clash of the air masses. And it's hard to say, and we call that a weather front. We're going to talk about that in chapter 9. It's hard to say where those are. But also it's kind of hard to kind of sink your teeth into where these air masses are, these different types of air masses, these 5 types of air masses. But they do it. So here they are, all kind of nice and neat and summarized here. Just to kind of beat a dead horse. Okay. Remember when you see these C's, okay, that stands for continental. These little M's, even though you could think of them standing for moist, they really mean maritime. The source region is a large body of water. Of course, the A is Arctic, temperature-wise. We have 2 polars. And then, last but not least, we have a couple of tropicals. Okay, so those are the 5 chunks of air with varying moisture and temperature, moisture content and temperature. So source regions. These are source regions. Remember we said the Ferrel cell, not a good source region. Hadley, polar, works, right? Notice also the title, and this is important. This is during the winter time in the northern hemisphere. So here we go. Not so surprising. I think this is one of the many things that makes sense about studying weather, meteorology. So actually, I'm going to have two white blobs up there. Notice they're both over continent. Well, this one's more over continent than this one. I don't know. Okay, but that makes them relatively dry, but they're cold. The one that's north, the northmost one, is very cold. So it's continental Arctic and then continental polar underneath that. Okay. Then we have a pair of blue ones on the side. Blue ones, again, meaning cold. Maybe blue meaning also stuffed with water vapor. Because actually these have dwelt, and this has dwelt in the Pacific, this has dwelt in the Atlantic, hangs out for a long time, gets moving inward, okay? So these would both be maritime, they're cold, maritime polar. And not so surprising, the red ones down there are going to be warm, so they'll have the tropical prefix since they're warm, and they'll have the M associated with their name because they're moist. So there you go. I have several source regions for moist tropical air masses in the wintertime.
Is there significance between the M, the lowercase and uppercase letters? Is there other letters?
That's just the convention. The moisture content indicated by maritime or continental are lowercase. Yeah.
There's a significance in that. But
Well, in
not-
physical science, they tend to kind of, they communicate, they try to be as standard as possible in communicating, so yeah. It'd be kind of like the elements going with kind of a mixed case there. They are case sensitive.
Where would the continental tropic be?
It's coming up, this is winter,
Okay.
okay. So that raises a good point. We're gonna switch gears, and on the next one, see what's different. One of the things you're gonna see, summer. We're gonna switch from winter into summer. One of the things you're gonna see is we don't have these two source regions up here. We only have continental polar. We don't have continental Arctic. Okay? So no continental Arctic, summertime. Okay? The things kind of look similar along the sides there. Maritime polar, pair of maritime polars from the Pacific and the Atlantic. You got it. Kind of an assortment of sources for that, in the summertime, for that moist, hot air masses. And, yeah, like he said, the one thing that's, since we lost the continental Arctic, what we picked up, though, was something called continental tropical. So, continental tropical, test question, is continental tropical source region to create an air mass only occurs in the summertime. And in this case, actually, the source region is just kind of, is within North America. So continental tropical, continental must mean it's dry, it's going to have some land form over, tropical meaning it's warm. So we still have these other warm source regions, but they're moist. Maritime tropical, continental tropical. Well, we said that a chunk of air needs to sit for a couple of weeks, and then it's on the move. And when it's on the move, basically, it's not in an insulated bubble. So there will be, and it's kind of, if this is the chunk of air moving over the land, the surface, basically kind of where it meets the surface, you're going to have kind of this exchange of heat and moisture. Okay? So what started out is, I'm going to show you some pictures here, but not so surprising. I'll use the globe to, what starts out is cold up here. Okay, it's going to migrate down, okay, and it's going to warm up. That's air mass modification, okay? If it picks up moisture and it was dry, that's also air mass modification. Makes sense. I've kind of heard it likened to picking up an accent. If you go to the South and you can start talking like them. If you're there long enough, you can become them. Which isn't all bad. Okay, so here's air mass modification, something starting out at a chilly negative 46 degrees Celsius, okay, and moving downward. Okay. By the way, you know, there's all sorts of different, I guess, types of, generally speaking, weather, but there's this thing called air mass weather that just basically says, a chunk of air that sat for a long time moved in on you, and you've got the characteristics that it had. So that's kind of what we call air mass weathers. But check this out. Negative 46, negative 33. Okay, so it's warming up. They might not think it's all that warm, Now that's Celsius. Okay. But this would still be considered, what, continental polar? Air
That would be horrible.
So this is kind of a hard figure to see, but I like it. Notice we have our 5 air masses over here, and we talked about where these 5 air masses form. Okay, this column up here says, is the air mass stable? And I mentioned just a little bit ago of the characteristics of an air mass that would make them unstable is if they're warm, and that kind of makes sense. Something warm's going to rise. The other thing is if it has a degree of moisture, because actually remember, moist air is less dense than dry air. Okay, so that brings a degree of instability. So how do we do that? So here, even though we have a bit of they're moist because it's maritime. The fact that they're cold are generally actually could be a mixed bag, doesn't it? Maritime polar air masses could be stable or unstable. Okay, here continental tropical, because it's warm, unstable. Okay, maritime tropical, it's really got it going on, because maritime meaning moist, tropical meaning warm. There you go, very unstable. Okay, then the top up there, okay, continental Arctic and continental polar, let's see, dry and cold, and dry and very cold. Okay, so they're stable, generally speaking. So, all right. So now my slides just kind of summarize each of the 5 air masses. So I don't know if there's anything I necessarily want to, let's see if there's anything we want to add here. So continental polar air masses, remember it's that one kind of over Canada, eh? Yeah, generally stable though. Lake effect snow. So lake effect snow, so you've probably heard of it before, can be associated with our Great Lakes. And basically, it's also a form of air mass modification. Let's see if I can see it right there. Okay. So air mass modification. And the air mass modification goes like this. Here in the Ferrel cell, we're under the influence of a prevailing westerly wind, right? There's our westerly wind. And let's just say in the fall time, we just start to get our cooler temperatures. And so basically over here on the west side of that Great Lake, we may have dry, cold air, continental polar air. Well, the lake it hasn't been cold all that long, so the lake has actually retained some of its heat from the fall and from the summer, and so it's warmer, so it's oozing water vapor. So thus the modification part, that air mass goes over that warm, that place where it's got a lot of water vapor, and some of that water vapor ends up in that chunk of air. So now notice it's not continental anymore. It's definitely has a degree of moisture to it. So it can cool, lift to the point of condensation. We get our clouds, and like I think the slide says, that slide said before, if over here the conditions are cold enough to make it to the ground as snow, it will. So this is lake effect snow. And so here's a figure from your textbook to kind of show you, of course, the bluer the area, the more the snow. So kind of look downwind where they get dumped on, and that's kind of what's happening. But in the meantime, it's just a couple minutes long, a video. Somebody grabbed a time-lapse video of a recent pounding they had in Boston. All right, air masses. So there's 5 different air masses, and the cold and dry ones, there's 2 of them, but one's colder than the other. So continental Arctic is just colder than continental polar, right? They're both dry. But we saw actually where in the wintertime, the source region for the continental Arctic might be here. The source region for the continental polar is here. So what you're seeing basically is there is a clash, or there can be a clash between those two air masses. And we call that the Arctic front. Okay, that's the Arctic front. And that's being shown here in these little blue segments. So here you have the bitterly cold dry air, and just the cold, dry air. This is the Arctic front right there. But not to be confused, actually, in the previous chapter, when we talked about where the polar and the ferrule cell meet, we said that actually is something called the polar front. So I like what your author's done to try to kind of distinguish between an Arctic front, which is just between air masses, okay, and the polar front, which is right here, which is basically lines up, okay, between, we're in the ferrule cell, right? The ferrule cell and the polar cell. So there's a slight difference there. Actually, big difference. In other words, the polar front's always there. Arctic front kind of comes and goes if those two masses are meeting. All right, Maritime Polar. We said that there were a couple of source regions. They're really not too bad if you just take your time and think about it. So maritime meaning moist, I need an ocean. Polar meaning north of us, right? So your source regions are kind of up here. You see the word nor'easter there? That's a type of mid-latitude cyclone. So here again with the modification, of course we said lake effect snow is an example of modification. Here's just another example of modification where clearly over a continent, right? So it's continental and it's upper latitude, so it's polar. Okay, but you can see where it's headed. It's headed over the Pacific Ocean. It picks up some moisture and actually can become, from continental polar, be modified to maritime polar. So one of the things you might be wondering is like, how long does it take an air mass to go? Like from that point to that point, that's quite a ways. Well, I guess it just depends. One of the things we talked about, I think, last time we met, is that sometimes there's a degree of waviness, and so things are moving, and sometimes things get stalled out. So I guess it just depends. Maritime Tropical, if you think about it, maritime meaning oceans, tropical meaning nice and warm. So our two source regions were kind of here. We had one over the Atlantic, one over the Pacific, and actually the Gulf can be a source region for maritime tropical air for us. But remember, as far as stability goes, anything that's warm, unstable. Anything that has a degree of moisture, unstable. So maritime tropical air masses, they definitely can be unstable. So speaking of unstable maritime tropical air masses, this is just kind of generally saying. So here's one thing I think we talked about this type of lifting mechanism. So basically, the ocean's nice and smooth. Continent, not so much. So basically what can be happening is you can have that chunk of air just moving. Maritime tropical air, it hits it piles up on the land. So we can actually, that's an uplifting mechanism right there. One of our source regions, aside from the oceans, is the Gulf. Okay, and actually, because of that source region, places like the south here, we kind of see all that blue, can get a fair bit of precipitation. So in the last chapter, we talked about two monsoons. We talked about a pair of monsoon seasons associated with, in India, with the Himalayan mountains. And we talked about monsoon seasons here in our southwest. It's that maritime tropical air masses that are giving us all that precipitation in the summertime. So we said continental tropical air masses only form in our summertime. Test question. So continental meaning dry, tropical meaning warm. Okay, very good. Let's do a few slides in the next chapter. So like I said, we're going to be talking about fronts here. So we talked a lot about air masses in Chapter 8, and Chapter 9 is looking at those air masses meeting. So we have a couple of possibilities. We have a couple of possibilities, I guess. Yeah, I have a chunk of air mass A, chunk of air mass B. Right between them is the front. You could figure that one is pushing into the other, or they're just kind of both hanging out. But regardless, there's a front between them. Usually where there's a front, there's a fire. No, really. Usually where two chunks of air masses with different temperatures and or moistures meet, that's where you're going to have some uplifting. Yeah. So a couple of different events here. The last unit of material, the last whole unit of material in here will start after your test, and we'll talk about severe weather. Of course, this looks like a tornado, right? Don't want to go out on a limb there, but yeah. So we talked about the 10 different cloud types, and of course cumulonimbus clouds are your thunderstorm clouds. And that oftentimes in the summertime, in the wintertime, that uplifting can bring us snow events. So here down there at the bottom, you see the 4 main types of weather fronts. And I'm going to kind of talk you through them, I think, on the next page. But I can tell you right now, and you probably already know this, okay, that the cold and the warm, they're called cold front or warm front based upon which air mass is doing the pushing. So with the cold front, the cold air is doing the pushing. With a warm front, the warm air mass is pushing into the cold air mass. The term stationary front means, the word stationary means not moving. So actually that is the deal. Either one, it's a standoff, stationary fronts. You have a chunk of air, and actually you can tell which side of the stationary front the warm is on by the direction of the semicircles. So the warm air, for instance, would be over here, and the cold air would be over here. And then the last one, it's a purple line usually. And notice it's different than a stationary front, even if you're colorblind, if you're looking at black and white image, because that if you look closely, you can see actually these are all on the same side. When I say same side, I mean you do have alternating kind of semicircle for usually associated with a warm front, and a triangle usually associated with a cold front, kind of alternating, but they're on the same side instead of a stationary front.
For a stationary front, is that like when you said they're just chilling?
Yeah, they're just chilling. Yep. So just to kind of reinforce that, I didn't mention it before, but cold fronts are usually blue, and they will be, they're triangles. So it kind of makes sense. It's kind of like pokey, right? So I said that with the cold front, the cold air is the aggressor. So here we would have some sort of polar air, right? Maritime Polar, or continental polar air mass, okay, moving this way. And this would be warmer air. So in our hemisphere, you're going to usually see them coming due from the north or kind of swinging down and around. Here we have a warm front, okay? So with the warm front, of course, warm air is the aggressor. And you can tell the direction that the warm air is pushing by the direction of the semicircles. So you can kind of see the semicircles are on the other side. So that would mean warm air is down here, pushing into cooler air. Stationary front. So like I said, you can tell which side that the different air masses are on if you look at the semicircles, and the side the semicircles are on and the triangles are on. So for instance, the semicircle on that side means that you have warm air over here, and the triangles on this side meaning you have cool air. And last but not least, an occluded front. So the one thing I will say about an occluded front is, since the semicircle and triangle are on the same side, I bet you guys would buy this, that basically you know that this thing is moving this way. the predominant motion is this way. It's always on the other side of, it's always on pushing towards the symbol. All right, so what your author does, and I used to kind of complain about it, I like this textbook, I picked it out, but he spends quite a bit of time talking about mid-latitude cyclones. But if you think about it, mid-latitude, that's us. Okay, that's Ferrell cell, right? So hey, that's okay. Because lower subtropics or the tropics would be the Hadley cell, we're in the Ferrell cell, and of course the polar cell's above us. Okay, so that's okay. The thing about mid-latitude cyclones is that I think they're kind of cool because they actually bring in ultimately all 4 of those fronts. You know, stationary, starts out as stationary actually front. Cold front, warm front kind of breaks into that, ends up in its mature stage as an occluded front. Okay, there's no dry lines there. But, okay, so mid-latitude cyclones. A few things about a mid-latitude cyclone is you'll see a big old L in the center of mid-latitude cyclone. And these can be very large, okay? So I know you guys have looked at weather maps before, and if you've seen that, it looks like it's a big L, but no, it's a big old L kind of in the center there. That may or may not be the beginning of a full-blown mid-latitude cyclone, okay? It is what we talked about earlier in this class. It is called a cyclone, okay, because low pressures are cyclones. High pressures are anticyclones. So one of the things we talked about cyclones is it has counterclockwise motion, and you can actually kind of see this counterclockwise motion. So I'm kind of bringing in things that we talked about before. Of course, this counterclockwise motion is deflection to the right when you start outside and move in. Okay, it kind of goes and it becomes what we call gradient wind, moving in the isobars. Speaking of isobars, those white lines are isobars. Okay, we said that isobars basically are lines connecting locations with the same pressure. So the thing about meteorology is that a lot of times the unit of choice in terms of pressure is millibars. So you can see it's a low because you're stepping up. So we have 992, 996, 1,000 millibars. It's like a bullseye, right? So mid-latitude cyclones, they'll have an L in the middle of them, right? Now, this is not a mature mid-latitude cyclone because it still does not have that purple occluded front. Talk more about that.
Since it's 1013 and be at like sea level, does that mean like that's like a weaker of the cyclones, or would it be like get lower?
Yeah, one of the things he's mentioning is that we talked about usually sea level pressure in terms of millibars is the 1013. Okay, that's just if anybody asks you. Okay, we know that barometric pressure can raise or low, and that's actually, you know, your barometers at home kind of go up and down. But I think you're got a good point. The lower this is, the scarier it is, quite frankly. So, because the lower your central low pressure, then that means that you might have quickly change your barometric pressure as you get outside of the system. And that means that you're going to have these tight isobars, which means you're going to have crazy wind. So one of the characteristics of, when we talk about hurricanes, after your test and stuff, one of the things about hurricanes is they look for, is it has a low too. Okay, so one of the things they judge about hurricanes, their intensity, is how low is the low. Low is bad. So, mid-latitude cyclones. Okay, so we'll kind of weave mid-latitude cyclones kind of in and out of this discussion. This is a very busy kind of slide. I'm not real thrilled with it, but if we kind of pick it apart, okay, one of the things I don't like is if you, let me choose green. These dotted line up here, that dotted line is not a front. It's just a dot, dot, dot to kind of show you a barrier between these two air masses. Those two air masses, notice the P's, they're both polar. Notice one's over Canada-ish, okay, continental polar, and one's over the Pacific, okay, maritime polar. But the other thing I want you to see, you see the low we've been talking about, okay? Do you see what's kind of extending from the low? And I might have just kind of obscured it. But that right there is purple. have to look really closely and see that the triangle and semicircle are on the same side of the line. That is an occluded front. This actually would be a mid-latitude cyclone in its mature stage. If we had those white lines, those isobars, you'd see them very probably tightly spaced around that occluded front. Of course, we have our cold front and our warm front. So that's kind of a mature mid-latitude cyclone. Idealized, I like how they said it.
How large would that cyclone be?
Well, you can kind of see it takes over the whole North
Okay,
America.
is that-
Yeah.
Okay,
But near the bullseye, near the center would be the nasty part.
okay.
But it can, and we're going to see, I was trying to find the year. I don't know if you guys remember when the Unidome collapsed, okay? I went there and I still don't remember it, but I believe that was maybe even the event that they allude to in this textbook for mid-latitude cyclones sweeping across the
It
states.
was late 80s, wasn't it?
Could be late 80s.
Thought it was 86.
Let's see. I graduated in, well, I don't want to say, but I don't know. Could be. We'll have to look that up. I bet that's a Unidome falling. So one of the things, and it's kind of a player, you're going to see it off and on, is that, and it makes sense if you think about it. Cold air in your house sinks, maybe. Warm air rises. So cold air actually, as we talk about just cold air, think of it as nice and dense. So actually cold air is going to be so dense it's going to hug the ground. That's actually, like I said, kind of a player in these fronts. So one of the things I like that your author does is he has these cool segments. So can you see this segment right here, the segment AB? And what he's done is basically to show it down here. Is that not cool or what? There's A and there's B. Kind of a cross section.
94.
In 94? Okay, that seems good, because I was not there then. I had my degree, so thank you. So we'll be talking more about this, but it's a good kind of introduction. Do you see what this cold air mass is doing to the warm? They call the word sector. I love this word sector. What this cold air is doing to the warm sector in front of it, and this warm air going what we call up and over. This is actually overrunning right there. I'm just going to kind of write the word abrupt. Does that look abrupt? It does to me. And this is actually kind of what we call overrunning. Okay. So anyway. So overrunning. Overrunning is associated with warm fronts. If I say it's a warm front coming in, that means the warm air is the aggressor. Warm air, though, is not stubborn. Warm air is not dense. Warm air will go up and over the cold air it's trying to replace. So what happens is we call the transition zone. Okay, let me pull this up here. I'll kind of mark the transition zone. This is the transition zone right here. Oops, let me pick green. So this transition zone right here, actually that is a nice slopey. I'll put slopey instead of abrupt. Not sloppy, slopey. So that transition zone has it's not steep at all. So that is what we call overrunning. And the cool thing about it is that actually if you are a little person here, okay, and this storm system is coming this way, well, I don't know about a storm system, but those clouds are coming there. Actually, what you'll see first are cirrus clouds, followed by a little deeper flat cloud, cirrostratus, and then you'll maybe see altostratus, and then you might get your precipitation. So kind of in that order. So there are some like farmers like old adages out there that basically says if you watch clouds, so those of you who are kind of interested in being able to look at nature and understand what maybe you have around the bend, if you see of a series of clouds, that are stratus clouds continue to get lower and lower and lower, that actually maybe be overrunning. And you might have precipitation on its way. Okay, so this is this. This, I'm not real thrilled about this. Usually I reserve, when I think of storm clouds, cumulonimbus clouds, I generally think of them as being associated with a cold front. But your author says, and he knows, or she knows more than I do, is saying that actually with a warm front, you can, depending upon what sort of air mass you're lifting, get the instability to give you your storm clouds. So this is kind of a cool little summary. It basically says, with regard to, this is all associated with a warm air mass on the move to where you are. Basically it says what would happen before your warm air comes, what would happen during the passage of the front, and what would it be like after the passage of the front. So I don't know. Sometimes I feel like posting this on the on my refrigerator and kind of seeing, is this correct? So before a warm front passes, your winds are generally east or southeast, and then afterwards your winds are from the south or southwest. I don't know. But I do agree, for instance, with regard to clouds, before the passage of the front and after the passage of the front. One of the things I'll draw your attention to is we said that, remember, a lot of times those little home barometers will say falling pressures, you can expect some sort of precipitation coming, okay? So notice that they fall, they continue to fall, and then after it passes, the pressure rises. So compare that to a cold front. And a little bit ago, I wrote the word abrupt. And I'll go ahead and write it again. Abrupt transition zone. And so basically that cold air is on the move and it's hugging the ground and it's basically saying anything in front of me, get out of the way. So it will go up kind of almost vertically. And so with that abrupt lifting, that actually creates a fair bit of instability. So not only that, but I think this is a test question. So not only is it that abrupt transition zone, but also I'm going to put the word fast moving. But the other thing is that cold air moves faster than warm air. So that poor lethargic warm air of it. So this one is the analogous to the one we looked at before for warm fronts. You can kind of see. For instance, if we pick on pressure, regardless of what the front is, you figure that they should be falling before the passage. Well, this is showing rising during the passage and after the passage. But anyway. All right. So stationary front is a standoff between two air masses. Remember, we show them with an alternating blue-red on opposite sides of the front line. Okay. Neither chunk of air is moving. So, though neither chunk of air is really making any headway with regard to the surface, we can still have some overrunning with that warm air overrunning the cold air. So, even with a stationary front. So that's a good time. We'll pick up here. We'll take a break, like a 10-ish minute break, and pick up here, right?